In this video, I'd like to talk about some of the basics of searching through collections of data. We'll call it simple. Let's say I have a bunch of data. 2, 5, -3, 22, 6, 4. Here's my data. It doesn't matter what kind of memory it's in or what kind of data structure it's in. It could be a vector, it could be a linked list. It doesn't really matter. I have a collection of data here, and it looks something like this. And I'm going to pose the question of, is the number 7 in this set of data? And I'd ask you to write me a function that searches through this data. And most of you could do this with relatively ease, like with a lot of ease. So you do something like this. For in I equals 0, well, I is less than the size of this thing, I plus plus, and you'd say if my array brackets I is equal to the value that you're looking for, 7, or this could be a variable or something, then I'm going to return true. Otherwise, I'm going to return false. This is what most of us do initially when we're doing a search algorithm, right? We are searching for some value over a collection. Now, this doesn't have to be integers. This could be like, I'm searching for the player Dave through my list of all the players that are currently online. You know, is Dave online right now? Or I am searching through for a specific item in the inventory of the player, right? It doesn't really matter. We have a collection of data, and we're looking for one specific item. And we do it like this, and we write these few lines of code. We do this all the time. This is what's called a sequential search. Sequential search. Also called a linear search. Oh, why is it called linear search? Well, because this takes linear time, right? So here, this is big O of n, right, which should be pretty easy for us to see. We've got I equals 0, I is less than the size. This isn't doing too much more. We've just got a subscript operator. So it's going to search through each element one by one, right? It starts here at 0, and it checks, is each one of these, as we go through, are any of these equal to 7? It gets to the end, nope, return false. Great. We've probably all written this a bunch of times, right? And so the next question is like, is this good enough? Is this good enough for all of the functions that we're writing to search through all of our inventory, our players, our whatever it is that we're searching through? And the answer typically is no. Remember that linear time complexity, it's okay, but it's not the best. This thing, if we graph it over time, is going to look something like this. It's just going to increase. As the size of n increases, our time is also going to increase at the same rate. So this thing is just going to get worse and worse and worse. And one thing that's really terrible about this is, imagine that this was a collection. You're building an MMO, and imagine that this is a collection of players who are currently online. When your game hits 10,000 concurrent users, and you have to search through 10,000 elements just to find out if someone's online right now, your game is going to slow to a crawl. You need something better. You need something faster. So what can we do? Well, in all honesty, there's nothing better you can do. This is probably as fast as you're going to get off of this data set. And the biggest reason why is because this data set is unsorted. This is not in any sort of method where we can do additional logic, better reasoning on top of it, because it's just random. It's not sorted at all, right? The best we can do is just, well, check each element for what it is that we're looking for and see if what we're looking for is in there, right? So really the next thing we need to explore is, well, how do we sort our data? Once we know how to sort our data, then we can figure out better strategies for searching our data.